Now let's talk about the model reflex agent. The most effective way to handle partial observability is for the agent to keep track of the part of the word it can't see now. So what it is saying that how we can handle the partial observation. So the thing is that mm, let's say you have the autonomous car, right? And this autonomous car is observing something or sensing something, but while it is sensing, it is not sensing the next percept in the reflex simple reflex agent. So as we have just discussed, the reflex agent will work on the current percept. So whatever the current percept I have, based on that I'll do the action. But what if the current percept is not a total observation? It might be the partial observation. Okay, so partial observation means, let's say someone has to move left. If some car has to move left, so what it will do is it will just make an indicator to move left. Okay, now if it is moving left, then definitely it has to do brake, and then it will make it slow down, and then it will move left. So in that particular the whole sequence, we should have the first of all, it will indicate left indication. Then if it is slow down, its car, and then only it will move. So it is not one percept. It is a sequence of percept. So if we have only one percept observation that it is moving left, that's all. So we cannot fulfill the requirement which we have to do. So that's why it is saying that the most effective way to handle parse out for the agent is to keep track of the part of the word that we cannot see. So we have to keep track that what it is going to do next. That is, the agent should maintain some sort of internal state that depend upon the percept history. So definitely we should have the sequence of percept. We should have what it is doing right now, what it is doing after that, what it is doing after that. And based on that, I'll make the action. So instead of taking only one percept, and based on that, you are making the action. This is the simple reflex agent. But if we'll take the history of it and we'll make the model out of that particular history, that is called model-based reflex agent. So the agent should maintain some sort of internal state that depend upon the percept history, that thereby reflects at least some of the unobserved aspect of the current state. For the braking problem, the internal state is not too expensive, right? For braking problem, the internal state is not too expensive. Means, see, braking problem, we know that the only one percept is enough. Just the previous frame from the camera, allowing the agent to detect when two red light at the edge of the vehicle do on or off simultaneously. So see, the blinking and somebody is going left. If there is a vehicle and this particular vehicle is moving left, so it will make an indication, and this particular indication will blink for some time. So we have to take the sequence of it. We have to take one frame, and then we have to take the second frame, which is off. Then again it is blinking, means in the third frame it will be on. So with this particular, I can get to know that it is moving left. But if somebody is braking means the red tail light is on. If red tail light is on, definitely I get to know that if it is braking. But if somebody is moving left, so I have to find out the sequence of it. One sequence is okay, that it is blinking. Another sequence should be off, then on, then off, then on. In that way, I'll find it out that somebody is moving left. So I should have the history of the percept and I'll make the model out of it. And then only I can perform the action based on that particular model. That is called model-based reflex agent. For other driving tasks such as changing lane, the agent need to keep track of where the other car are. If it cannot see them all at once, and for any driving is to be possible at all, the agent need to keep track of where it keys are. This knowledge about how the world works, whether implemented in simple Boolean circuit or a complete scientific theory, it is called a model of the world. An agent that uses such a model is called model-based agent. So the model means we should have the percept history, and based on the percept history, or you can see that we'll not rely on the, we are not going to rely on the only one or the partial observation. We should have the sequence of percept history, and based on that we'll make the model, and this particular model will give some action, and based on that action we perform the action through the actuator, and that is called model based agent. Okay, so I hope you understand. The simple reflex agent will work on only the current percept, but the model based reflex agent will not rely on the partial observation. Instead, it will take the percept history, and based on that it will create the model, and the model will define the action, and it will perform the action. That is a work of model based reflex agent. So if you if you see this particular diagram of model based reflex agent, so what are the thing we have? So we have the sensor, right? Sensor will sense the current percept. This current percept has this state, how the word involve, what may action do, means it will make a history of it. This particular history, it will just see into the condition action rule in the table. And based on that, whatever rule, whatever action is there, the actuator will perform the action. So here the sensor is not looking the current word. Actually, it is making the state and how the word is evolve, and how the word or the uh, or the environment is changing. Based on that, it will make the, it will find out the action rule, and this action will be performed by the actuator. Let's see the same thing with the help of this algorithm. So in this particular algorithm, as you can see, this is the model based algorithm. In this particular model based reflex algorithm, it is taking the input as the percept. So everything is input as the percept. But the thing is that it is making the state of it. The agent currently current conception of the word state. So let's say if it is in one state, let's say one blink is there. So in one state means, let's say this is one blink on. The blink is on. Let's say the left blink is on. Then the second percept, it is saying off. Then in the next state, it is making on. Then what is the conclusion of these state? The conclusion of this state is the left indicator or the right indicator is blinking. Okay, this on, then off, then on. It means that blinking. So in that way, it will make the state. It will make the state. Model, the description of how the next state depend upon the current state and the action. How the next state is depend upon the current state and the action. The rule, the condition is there. There is some rules and the regulations in the form of tables. So if it is this is my model one, then this action has to be performed. If this is model two, then this action has to be performed. So all these things are defined, and action are nothing but the most recent action is there. Now with the help of a state, action, percept, and model, we give all these things into the update state, and based on that we'll update the state, and this state will find out the rule, and this rule is defined sum of short of actions. Okay, so instead of taking only one percept, we have the history of the percept, and these history of the percept we have done simple modeling, and based on the modeling we define like this is the action and this is the rule that we have to follow. That is defined into the model based reflex agent. So instead of taking only one percept, we'll take the history of the percept and we'll do the model.